Chandel, Amarpreet Singh, Deepak Pandey, Rinal Shok, Pratyush, Ramya Devi, Parthi M, Saravanti. So let me clarify to all the students, okay, that the instruction language for this course will be in English, okay, because we know that we have a joint type of students. Some students are from south, and we have students from north as well. So I hope that a certain level of English is everybody is comfortable. And regarding the doubt, okay, clarification can be in English as well as Hindi, depending on who asks the question. So let us start. So, so I'm going to teach you electronic devices and experimental method. So so let us first discuss the syllabus of this course. So this topic has mainly two parts. One is analog circuits, because this course is all about devices, okay, mainly on devices, okay, and devices and their application. So we divide it in two parts. One is called analog circuits, and other part is your digital circuits, digital electronics or digital circuits, okay. Now first we are starting this your analog part, and if you see the analog part, which is mainly the devices part. So if I put the syllabus, so syllabus can be summarized. So syllabus, okay. So the first part of the syllabus will be your network analysis, okay. Now any electronic course, okay, you all know that for any electronics course, the basic requirement is circuit analysis, okay. Students should have the skill of solving any circuit, okay. So that is a fundamental requirement or basic requirement for any electronics course. So although this topic is not mentioned in your syllabus specifically, but it is understood that without knowing this one, it is difficult to handle any electronics course. So the first, so that's why we are putting this as our first chapter, okay. And the second chapter will be your PN junction, okay, physics of PN junction, physics of PN junction, okay. Now because this course is about the application of electronic devices, and we know that all of the electronic devices used in the today's circuits is made of PN junction, okay. Whether this diode is a itself is a PN junction, then you have a transistor which is also made of two PN junctions, then you have a MOSFET, FETs, okay. So all the mainly LED solar cells, okay, everything is made of PN junction. So PN junction is the essential unit, okay, or essential part of any electron devices. So I'm going to deal this chapter separately, okay. And the third chapter will be, now will coming up to main syllabus, there will be diode and its applications, diode and its application. And the fourth chapter will be, so application means we learn how to deal diode in a circuit, and applications will be like your rectifier application, okay, clipper circuits, clipping, then you have a clamping, then you have a Zener diode, And there are some special diodes also we'll discuss, Zener diode. And then you have a voltage multiplier. And then we can design logic gates using diodes, that also you will discuss. So logic gates using diodes, voltage multiplier circuit, voltage multiplier circuits. Okay, so those everything is comes in the diode chapter. And the next chapter will be your transistor. Mainly we'll discuss bipolar junction transistor. Okay, so transistor also has a two part. So we know the main use of transistor is in amplifier circuits, amplification. And if I want my transistor should work as an amplifier, I need to apply certain kind of biasing to it. Okay, so the first part will be DC biasing. Okay, which is essential for operation of transistor. Transistor has a mainly three applications. Okay, one is amplifier, then other is switch. Okay, switch off, switch on. So there are three regions: active region, cutoff region, and saturation region. So each kind of operation requires certain kind of biasing. So that comes in DC biasing. And once we have biased the transistor for a particular application, then next comes the amplification part. How to amplify, that comes in the AC part, AC circuits of transistor. So that is a two part of transistor. And the last topic will be your operational amplifier. Operational amplifier. Okay, and there are many applications of op-amp. Okay, like I want to integrate a signal, I want to differentiate a signal, addition of voltages, at subtraction of voltages. Okay, logarithmic amplifier, oscillator. So those all applications using op-amp, it is in your syllabus, and we are going to deal with this things. Okay, now comes the books part. Okay, so let me clear that initially the pace of the course will be gradual. Okay, because we have some young students also with us, like Parthi is first year student. Okay, and I am planning to take that for GEM students. Okay, because they are young student, I am planning to take separate tutorial class or problem solving classes for them, if for the condition the slot should be available, because these students are young. Okay, they require a little bit more attention. So we'll see how can we do this. Now comes to the books. Okay, what books we are going to deal. Okay, so there are two books mainly. First, for network analysis, and for network analysis I am going to use the book name Fundamental of Electric Circuits. Fundamental of Electric Circuits. Okay, this book is written by Alexander and Matthews. So Charles K. Alexander, by Charles K. Alexander, and that is Matthews. I will show you the books. Matthews, Anno Sadek. You might have heard the name of this book. Very nice book for fundamental electric circuits. Okay, so you have to, the soft copy of this book is available in your Google Classroom. If you don't find, let me know, I will share it again. So this chapter, in order to handle this chapter, I'm going to discuss mainly this book, plus you have to use my class notes. Okay, so along with these books you can use my class notes. Okay, now physics of p-n junction. Okay, my class notes will be sufficient. Okay, something will be given in Ballstead books also. Class notes is sufficient. Then diode in application and transistor. Okay, so mainly for this part, my class notes will be sufficient. Even for op-amp, my class notes are more than sufficient. You don't require any book as such, but still, if you want to, you want a book name, okay, for this part, okay. So this from 2 to 5, okay, for this 2 to 5 section, for 2 to 5 section, you can have this electronic devices and circuit theory book by Bolstate. Okay, so let me write the name: electronic devices and circuit theory. Devices and circuit theory. Okay, and this is book by Bolstate. Okay, famously known Robert Bolstate. So I'm writing only Bolstate. Bolstate. Okay. So these are the two books which we are mainly going to use. Okay, I'll show you the both of the books. One is your this fundamental of electric circuit book, and second is your devices book. So these two books I'm going to use in this course, along with my notes, study material of Pravega OS Center. Okay, all three parts, three things, three resources you have to use for your preparation for your exam. So very interesting topic is electronics. Okay, easy also. Always, if you 2 to 3 questions will become from your analog part, and similarly 2 to 3 questions will be from your digital part. Okay, so let us now start with a network analysis. If you have any confusion, you can ask me now about the syllabus. So otherwise, we will start continuing. We'll start our first topic, network analysis. Okay. So let me start with network analysis. Okay, this is the essential topic. Okay, everyone. So initially we'll go very slow, as I told you earlier, because the command on electric circuit is necessary. And once a student have command on this topic, okay, gradually we can increase our pace. So let us start with the network analysis. Okay. So let me first introduce what is network is actually. Okay, what is network? Okay, so generally in physics student, as a physics student, we generally use the word circuit. Okay, circuit and network. Okay, so they look like a same word, similar word, network and network or circuit or circuits. Both words are in general communication are used interchangeably. Okay, but there is a slight difference between the definition of network and a circuit. Okay, what is network? So first let me discuss circuit. Okay, circuit is what? Circuit word comes from the circle. Okay, this word is come from circle. Okay, and of course, when I say circuit, okay, circle of what? Circle of network components. Okay, network components means you have a resistor, you have a voltage source, current source, capacitor, inductor. Okay, all these are called network elements or components. Okay, so circle. So the definition of circle is a closed path. Okay, is closed path having energy source. Okay, a closed path, circle means a closed path of electrical component. Electrical component having an energy source, having an energy source. Energy source is compulsory and we close path of network elements, okay, which must comprise or must consist a energy source, then that is called circuit. Okay, now if I say network, what is a network? Basically the definition of network is same, but network doesn't require an energy source. Okay, so network is an interconnection of network elements. Interconnection of network elements. Now what are network elements? Network elements. So network elements means I'm talking about a resistor, inductor, L, short writing L. Okay, it's an inductor, resistor, then your capacitor C. I'm denoting by in short. Okay, then you have a voltage source, energy source, voltage source, current source, or electrical components. Okay, current source. Then you have a diode, transistor, op amp. These all are network element. So interconnection of these network element is called network. Now, what is the difference between a circle and a network? So let me explain this, the difference between by an example. So as I told, the requirement of a network to be called is that there should be essentially an energy source. Okay, for example, let me draw a circuit or network. Say this is my voltage source. Here say I have a resistance, say R1. Say I have a resistance R2. Then I have a resistance, say R3. Okay. Now this, in this part, if I consider this thing, okay, okay. So this is my circuit because this is the closed path having resistors and have this is also energy part. Okay, so this section of this part of this network is called circuit. Circuit. Okay, circuit should be always closed. It cannot have a open terminals. It can have a cannot have a open paths. Okay, for example, this part has a is open terminals. Okay, so I cannot so I this is so this part is a circuit. Okay, and this is also network. So every circuit is a network, but every circuit is a network. Okay, but all the networks are not circuits. Okay, or you can say all the circuits are networks, but all the networks cannot be called circuit. For example, this is my circuit. Now suppose if I remove this resistor here and I make it open here, so this is not a circuit because now this is open channel or open path between the circuit, but this is a still network. Still this can be called a network. Network is a simply interconnection of electrical component. It should not have any break. Okay, but circuit, it can have a break, but circuit should be closed without any break. So this part of the network, this is, for example, this is small section is a circuit, but if I open this one, still this is a network. It's not a circuit, but still it is a network. Okay, network also can be active. Network can be active. Network can be passive. But circuit cannot be passive. Suppose if I remove this parts, this source now from here, still this is a network, but now this become a passive network. So now this become a passive network. If If source is present, then it's the active network. If source is not present, only resistors are there, capacitors are there, inductors are. So any, if you join them randomly, okay, still this is a called network. But in order to become circuit, we require the must requirement is it should have an energy source, plus this should be closed. So in the final statement, what we can summarize that all circuits are network, all circuits are network, okay, but all networks cannot be called or are not circuits, okay. So you can say the network is a set and circuit is a subset, okay. It's a section of part of the any network, okay. So that is the main difference between a circuit and network, okay. So if it is clear to everyone, I can move further. Now if I want to deal in network, okay, in a circuit, I require some language, okay. If I want to understand, if I want to talk to you, or if I want to understand, okay, we require some language, okay, some naming. So I should know the basic terminology, okay, used in electronics, okay. Then only we can communicate, we can understand what we are what things we are discussing. So there is a basic terminology required to understand a network, okay. So next topic is your network terminology. Network terminology, okay, what we are going to discuss in the network. So so let me draw one more network. Say this is my energy source, say voltage source. I am using a resistor, say R1. Say I am using a resistance R2 here, okay. Let me use one more resistor R3 here, and let me put a current source here, I, okay. So say this is my current source. So current, we have to show by direction. So this is my, say this is my current source, okay. So this symbol I will be using for a battery, for voltage, okay, voltage source, this symbol, plus a, I can use this symbol for battery, or a for battery. For if you have a more number of voltage source, like this is a 1 volt, 2 volt, 3 volt, I can use this one. If you have a more voltage, high voltages, okay, then sometime instead of this using this one, we can use like this is the battery sign, okay. And if I use like this will be using you use for your current source. So now what is terminology, okay. Let us understand that what is network. So these all sections, these are terminals, okay. These are all terminals. Terminals means where we are joints. These are all terminals, okay. Now the most important terminology is we are going to use, that is called node. What is node? Node in a network, or node in a circuit, okay. So and these are terminals, 1, 2, 3, 4, 5, 6, 7, 8. These are 8 are terminals, okay. So we have 8 terminals here. Just for showing, it may not be 8, okay, because this, they all are joined in this part. So this is a single terminal, okay. So just for looking, I have put 8 dots, so I see 8 terminals, okay. So what is node? So node is a terminal, okay, where where two or more components. Components means electrical network elements. Components 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 joined together. Okay, so a terminal where two or more component electric network elements joined together. Okay, so say this is my A terminal, B terminal, C terminal, D, say this is E, this is F, say this is G, this is H. Now tell me how many nodes are there in the circuit? Can anyone tell me कितने nodes है इसके अंदर? How many nodes are there in this network? How many are there? Count. Tell me how many how many terminals how many terminals qualify this definition? Okay, Akansha, Amarpreet, Ramya, Pratyush. Can you tell me how many nodes are there? Anyone?
5, sir.
5. Okay, 5. Anyone else? करिश्मा, कितने हैं? कितने नोड है इसके अंदर? काउंट करो। और कौन कौन है यहाँ पे? प्रत्युष, पूजा, कितने नोड्स हैं यहाँ पर? So what is the definition? A terminal where where two or more components join together. तो यहाँ पे in this place, how many components are joining in this terminal? How many components are joining here? Two components are joining. So this terminal qualifies the definition of node. Yes or no?
Yes.
So this is a node. So this is a node. Okay, this is a node. Node A. Here, how many components are joining? Tell me. 2 or 3?
3.
This one, and this is a wire only. This is a connection wire. Okay, these are short. These are, tell me. So in this point, 1, 2, 3, 4 components are coming because this point, and this point, these all 3 points are same. Okay, I cannot say these terminals are not different. Okay, like I have to connect just for representation in rectangular way. Okay, just for simplification, we are drawing this wire. Otherwise, in the circuit, this line is not required. Basically, this resistor directly can be connected. I can pull this terminal, I can connect here. Similarly, I can connect directly these two terminals here. So these B, C, D are not separate nodes. These nodes are short circuited because they are short circuited. But the wire I'm shown with the circuit by a simple conducting wire. It is short. So this whole three terminals make a single node. Okay. So this is the node. These 3 points is make a one terminal. Okay. These are one terminal. I can join this like R2 I can directly join here, like here. I can join R3 directly with here. Similarly, I can join this source like that directly here. So these three things are merged on a single point. So this is only one node. This is not a different nodes. These are single terminals. Okay. So this is a single. This is similarly, if I say this 1, 2, 3, 4. These all terminals are one point. These are all short. So these all terminals make only one node. So if I say how many nodes are in the circuit, the number of nodes n is equal to 3, for given circuit. Okay, so whenever I say node, you apply the equation on node. You should understand what is a node. Okay, there's a node, two node, three node. Okay, there are three node. Okay, this is the most important definition, because depending on this node, there are some methods for network analysis. Methods have name. Okay, like a nodal analysis. So that's why we should understand what is a node, meaning of node. Okay, then the second thing is your branch. Okay, branch. So a component between two nodes is called a branch. So it is very simple. Branch means what? Branch means if any component comes between the two nodes, it is a branch. So obviously the number of branch is equal to number of components. Each component is one branch, because this component is surely between two nodes. Okay, this is surely between two nodes. This is between two nodes. This is also between two nodes. This is also between two nodes. So in order to count a branch, you don't require anything. Okay, you just have to count the number of component present in the circuit. So 1, 2, 3, 4, 5. Okay, so the number of branch in the circuit is 5. Okay, so number of branches in the circuit is 5. Okay, now third thing comes, how many loops are there in the circuit? Loops. Now loops means a closed path. A closed path in the circuit is called loop. A closed path is loop. How many loops are there in the circuit? Can you tell me?
Sir, 6.
6. Okay, anyone else? Amardeep, how many are there? Parthi, how many closed loops are there? Can you count?
6, sir.
6 है, 6 है, okay? 6 है. How 6? So A, B, G, H. This is the closed loop. A, B, G, H is the closed loop. B, C, F, G, B, C, F, G. This is the closed loop. Then you have a C, C, D, E, F. C, D, E, F is a closed loop. Okay, सारे closed path है. These all are closed paths. Okay, and then you have A. If I can go directly from here to here to here, here, I can say A, C, F, H is a closed path. Similarly, I can say B, D, E, G. B, D, E, G is a closed path. And I can take a bigger loop, larger loop. I can say which encloses all other loops. Okay, so which is called your A, D, E, H. ये क्या है? This is our these are our 6 loop. So L is 6 in this given example. Now generally I don't require loop. Okay, but I require mesh. Okay, mesh is the special kind of loop. Okay, so there is a slight difference between a closed path. A closed path, mesh is also closed path. Okay, but that is some variation in definition with respect to the loop. Mesh is what? Mesh, because you know in a school you're using a technique mesh analysis, nodal analysis. Okay, so you should know what is actually mesh first. Okay, so mesh is what? Mesh is your a independent loop. An independent loop, independent loop. Okay, what do you mean by independent loop? Independent loop का मतलब है, the meaning of independent loop is that it does not contain any loop inside it. Okay, so an independent loop. Okay, independent loop means a loop which does not contain contain any loop inside it is called a mesh. Okay. How many meshes are there in the circuit? Tell me. How many meshes are there in this network? Now I will use what is like three. Okay.
Three.
So there's only three. A, B, C, this one, this one, this one. So number of meshes are only three. Okay. Because if I say A, C, F, H, this is not an independent loop because it contains this A, B, G, H inside it. Okay. Then if I say B, D, E, G, it contains B, C, G, F, G inside it. So I cannot call this is the loop mesh. Okay. So the only independent loop, this is the independent loop. This is a thing, this is a separate loop, this is a separate loop. This is called your mesh. The number of meshes m equal to 3. Okay. Now there is an important relations between these numbers. Okay. So generally, if I want to find the branches B, so my B plus M plus N minus 1. So any network, this relation holds true. Okay, if I know the M and N, I can find how many branches are there. For example, in this given question, my M is 3, N is 3, minus 1. So this give me 5. So out of this three quantity, if I know the two quantities, I can tell how many. If you're not able to identify, sometimes if you're doing mistake, you can use this equation, and you can tell if the three loops are there and there are five branches, three branches are there, then of course there should be how many, there should be three nodes should be present in the circuit. So if you're missing some node, but by seeing the circuit you can adjust. Okay, now with practice it will be very easy. You can easily say this is node, how many nodes are present. Okay, this is very, so this is the terminology. Okay, even though if you don't know this terminology, still you can solve the circuit, but but it is good to know the terminology. Like and you can ride a car, you can ride a aeroplane also. Okay, but if you know the different section of parts, the naming of this part, that has become good. Okay, it is some, at least for communication purpose, understanding purpose. Okay, you should know the names, okay, of the things. You can go without these names also, you can solve in circuit, because everything is in your memory, in subconscious mind. You know what is resistor, you know what is Ohm's law, everything you can do it. But for systematic way, okay, you should understand the terminology. That's why I have discussed these all the things. Okay, uh, these things. Okay, so let me just for practice one question we will solve more, so that I can understand that students are uh, getting what I am discussing. I will give you one more circuit. You have to count the number of branches, meshes, and nodes. Okay. So say if I say this is my voltage source, say this is R1, say this is R2, say I am putting here a current source here. Can you tell me how many node say price, how many nodes are there in the circuit? How many nodes are there in the circuit?
Sir, three.
3. Anyone else? Amardeep, how much?
Three.
3. Okay. So these are short circuited. So these are not separate. So this is a single. This is a one node. This is a second node, and this is a three nodes. Okay. So and is equal to 3 for this circuit. Tell me how many meshes are in the circuit? Meshes, how many?
Three.
3 meshes, also 3. 1, 2, 3. Now branches will be how much? 3 plus 3 minus 1, 6.
Five.
6 minus 1, 5. So 1, 2, 3, 4, 5. So branches is nothing. Branches is a number of components present in the circuit. So 1, 2, 3, 4, 5 are present. You can make any other circuit, okay, and you can have a practice. Of course, after each class, I'll send a small tutorial, okay, and once we have covered a few classes, that there will be short class tests also, and then your website there are long sections of tests that also you can do it previous set problems. So this is basic terminology of network. Okay, ये तो हो गया नेटवर्क हो गया ना. अब हमको करना क्या है, व्हाट वी वांट टू डू. ओके, वी वांट टू बेसिकली solve a network. We want to have a skill, we want to have practice or network analysis so that we can handle devices, understand the application of devices, how the devices are working. Okay, so basically what I'm looking for the voltage, current, power, how much voltage is there in across any component. So network analysis means finding the voltages and currents, voltage, current, and power in each component of the circuit, across each component of the circuit. Okay, because there will be some components which will be giving the power, like energy sources that will deliver the power. There will be some component which will be absorbing this power. Okay, power, like resistor, there will be power loss. Okay, there will be some component which will be something will be storing, like capacitor. So network analysis is what? Network analysis is the finding the voltages, currents, finding voltages, currents across, and power can be absorbed, power can be delivered. Okay, finding the voltage, currents, and power across any component in the network, across any component, or across, they can be asked in the question, find the voltage across all components. So when I say network analysis means solving everything. Okay, so finding the voltage, currents, and powers across any component, across all components, if I want perfect analysis, you want to solve everything, then I should know what is the current flowing in each branch, what is the voltage across each branch. Okay, so finding the voltages, currents, and powers across all components present. Okay, all components present in the network, that is our purpose mainly when I say circuit analysis. Okay, now let us first, what is voltage, current, power, that also we should know. You, of course, you know these things, you have discussed, you are reading these things from your school onwards. Okay, let's just for completeness, let me give you this definition. Okay, so if of course you want to find the charge also. Okay, charge is the fundamental property of fundamental electrical property. Okay, so there are, so we'll want to find about how much charge is flowing across any branch. So the first things we are looking for, charge. Okay, well, charge is what? Charge is a fundamental property of metal. Fundamental property of matter. Okay, now we know the charge is quantized, so Q is equal to NE, and where E is what? E is electronic charge. Electronic charge. N is what? N is a number. So charge can only be quantized. Zero means zero charge. And only N is 1, 2, 3, 4, 5. Okay, 5. So the unit of charge is coulomb. So if I ask you how many electrons joined together make a 1 coulomb. So how many electrons is the number of electrons? So that charge can be 1 electron, 2 electron, 3 electron, 4 electron. If this is a 1 coulomb, then how many numbers of electron you require to make a 1 coulomb charge? So if I want the numbers, so 1 coulomb charge, number of electrons in 1 coulomb charge will be how much? N will be Q by E. If I say, but this is 1 coulomb, and electron charge is 1.6 into 10 raised to power minus 19 coulomb. Coulomb unit cancel. If you solve this one, this will come out 6.24 into 10 raised to power 18 electrons. So this many electrons make one charge. The charge is a very larger unit of coulomb is a very larger unit. Okay, generally we use millicoulomb, microcoulomb. Okay, in the circuit. So this is the charge. Now the next definition is what is current. Okay. So next quantity which we are looking for in the circuit is called, this is all this just for introduction, okay, because today is a mainly introduction class. We'll solve some small problems also, but first we should know what is the fundamental, what we're going to do in this course. Okay, so this is a charge. The second thing is current. What is the definition of current? Can anyone tell me?
So current per unit time.
Current तो पूछ ही रहा हूँ.
Sorry, charge per unit time.
Charge.
Flow of charge.
Flow of charge, very good. Okay, so rate of flow of charge, rate of flow of charge is called current. Generally, mathematically, okay, mathematical definition, mathematical definition of I is dq by dt. Okay, dq by dt, rate of flow of charge. Now, how does charge flow? Okay, generally when I say charge is flowing, okay, charge can flow in a conductor, in a semiconductor. Okay, generally we when I say simple first elementary, charge is flowing where? Charge is flowing in the conductor. Okay, so let me make a conductor now. So this is my conductor. Okay, and here the charges are present, and charges in the conductor are electrons. So here electrons are present, but I want to make them flow. I want to accelerate them. I want to make flow. At least not do not not if you are not accelerating, at least they're moving with some speed, some constant speed. Okay, so if I want to move this thing, because these charges are charge are there, and charge cannot move until you don't apply force to them. Okay, because without force nothing moves. If your force is not there, particle cannot move. And if you want to move a charge particle, you need a electric force. You have to apply electric field. Okay, an electric field you can apply, you can create an electric field only when you're creating a voltage gradient. Until you don't create a voltage gradient in any section of this rod or in this conductor, you cannot force electron to move, because you cannot apply force. Force is what? QE. If you want to move a charge, you need to apply a force. Force is QE. Electron charge is minus. If I want to force on electron, this will be EE. Okay, minus charge. So I have to so this force electric field will be in different direction, opposite direction, because the minus is charge is there. So I want to move this electron, and so these charges can be moved only by electric field, and electric field only can be produced by voltage gradient dV by dx. Until you don't create dV by dx in the section of material, you cannot create an electric field. So what I'll do, I'll apply a battery here, plus minus. So this is the ground, and here is a voltage V. So I am creating a voltage difference of V. Okay, I am creating in this say this end is A, say this end is B. So I am creating between A and B a voltage gradient of V. And if I say the length of this rod is conductor is L, then I can produce a constant electric field. I'm only talking about the magnitude E equal to V by L. And when I apply a battery, there will be electric field, which direction will be from A to B. And now because of this electric field, the electron present in the section will experience a force in the opposite direction, and electron will start moving. Electron will start moving. So this is the how we set up a current in a conductor. Okay, of course you know these things. Just for completeness, I'm doing this. Okay, now now the current direction will be always opposite to the movement of electron. If electrons are moving in this section, I say my current is always opposite to the electron, because by definition current is defined positive charge movement. Okay, So current will be opposed to this one. Electric field is this direction. So current will be also in this direction. But electron is actually flow is in opposite direction. But just for mathematical convenience, in avoid to negative sign, we are saying the current is moving in the positive direction. Okay. So you know the I is equal to dq by dt. If you have a dq, so dq will be your I dt. And if you want to integrate this one, you want to how much charge is flowing, if you know the current, okay, if you know the current may be constant, current may be time dependent. And if you want to know from t1 to t2 term how much current is flowing in any point, you can find how much charges has gone through that point in time interval t2 minus t1. So these equations you can use if you want to find the charge, okay, किसी पॉइंट पे, किसी सेक्शन पे, किसी टाइम इंटरवल में कितना चार्ज मूव हो गया, how much charge has passed that point, you can use this equation. Okay. And the next important quantity is voltage. Okay. What is voltage? Generally in circuit we come across voltage difference, not a voltage. So but okay, what is voltage or voltage difference? Voltage or voltage difference. कोई बताएगा मुझे definition? What is the definition of? Can anyone tell me what is the definition of voltage?
Voltage may be defined as the work done in moving a charge from infinity to a particular point in the electric field.
Yes, very good. Okay, so if you are talking about a voltage, okay, work done from moving a charge from infinite to some point, okay, it's called voltage. But in circuits I concerned with the voltage difference. So voltage difference, okay, if I say voltage difference, V is called dw, this is a work done and moving a charge, okay, dw by dq. So you for moving one charge from one point to A, suppose if there's a point A.
Sir, is the subscript AB, sir? W V of AB?
Huh?
What you written?
Yes. Okay. So say this terminal is B, this terminal is A. Okay. Now how much charge, the voltage difference this point depends on how much work has to be done to move charge from B to A. Okay, so this voltage difference is called VAB. For example, say, let me give you 1 minute. Just give me 1 minute. Tell me, any question? So if I want to, so when I say the voltage difference is VAB, or if I say let us say I say this is my point A and this is my point B in the circuit, and if I say this is my plus 9 volt, which is my VAB is 9 volt. If I say my VAB is 9 volt, that means my VAB means here, VAB means VA minus VB. That voltage of A with respect to B is 9 volt. If this is the 15 volt, if I say this is the, if difference is 9. So if this is a 15 volt, this will be how much? This will be how much? VA, if VA is 15 volt, VB will be
6 volt.
6 volt. If I say VA is 9 volt, then my VB will be automatically 0. Okay. So assuming this is, if it is a 6, then this is the 15. If it is a 9, then this is a 18. If it is a 0, this is a 9. Okay. So voltage is always measured with respect to something. Okay. If you want only voltage, because infinite we generally say voltage is 0, that's the way we define the definition of voltage. Okay, but circuit I always require a voltage difference. So and you have to understand always that my VAB will be equal to minus VBA. So the same thing, if I want what is the voltage of B with respect to A, then this will be minus 9 volt. Actually, this is a 9 volt, it is a 0 volt. The difference is this is a higher voltage, this is a lower voltage. If I want VAB, this is a 9 volt. Okay, so VAB is 9 volt. And if I want BBA, that will be opposite to this one. This will be minus 9 volt. Let me give you one more example. Say this is my circuit. This is my resistor. And the voltage difference between this is a higher potential 9 volt. Say this terminal A, say this terminal B, and say this is my grounded. Now, if I measure the voltage AB, so when I say I'm measuring the voltage, how I am measuring the voltage? You cannot, you have to, if you're measuring something, you have require some instrument, some device to measure this one. Of course, when I say I'm measuring VAB, I'm measuring the potential A with respect to B. When I'm measuring voltage AB, I have to connect this with a multimeter or voltmeter. Okay, and voltmeter, so say this is the plus of voltmeter, this is the minus of voltmeter. So whatever point I want to measure, the plus of this one we have to put here. If I want to measure voltage of A, which would be this plus sign will be here. So if I want to measure VAB, then this is, suppose this give me 9 volt. So basically I am, when I put this sign plus minus like this, the condition, I know the which is higher potential. This is higher potential, this is low potential, this already I know. Okay, and now I am using the, I am putting plus minus here. Whenever there is a plus minus here, that means I am putting my I am measuring the voltage here like this. Say this is V1. So my V1, which is nothing, which is VAB, is 9 volt. Now same circuit, if I say no, I don't want to measure like this, I want to measure the voltage of B with respect to A, I can put plus here and minus here. This plus minus is for measurement. Actually, depends which is higher potential. If current is moving like this is higher potential, this is a lower potential. Now, suppose if I put a voltmeter, if I put a sign here, that means now I'm measuring the voltage of this point with a voltmeter, and now I'm measuring V2. Say if I say this is now V2, so V2 will be your VBA, and this will be minus 9 volt. Okay, so you always understand that meaning of this plus minus will be given on the circuit. What is the meaning of this one? So meaning of this one, I am measuring the voltage like this. If the voltage is like this, sign is like this, I am measuring the voltage oppositely. So oppositely, this is coming 5, this will come minus 5. So VAB is always equal to minus BBA in the circuit. We'll discuss this thing when we'll solve the problems. Okay, so basic should be clear. Okay, what we are doing, that the meaning of this plus minus should be clear. This is meaning how I am measuring the voltage in the circuit. We'll come to on these things in detail. Okay, so this is the definition of voltage, and the last definition is your power. Okay, the last definition is power. What is power? The rate of work done is called power. Rate of work done. Okay, that is power is dW by dt. Okay. So, or rate of power done of, or rate of energy flow. Generally, we write this is a dE. E is energy. Okay, rate of work done or energy flow. Energy flow. Okay. The energy, the difference in the definition of energy and power. Energy का मतलब क्या होता है? Energy means my ability to do work. Okay, if I have more energy, I can do more work. But power is the delivering the energy, how fast I can deliver that energy, or how slow I can deliver that energy. That defines my power. Okay, so some sources have a high energy, some sources has a low energy. Like capacitor, it has a very low energy. Okay, if it is if nowadays when there are many capacitors coming, which energy storage capacity is very high, but in generally in conventional capacitor, where the capacitance is microfarad, picofarad, okay, they have a very little, they can store very little energy in millijoules, okay, but they can deliver that they can deliver that power very fast, okay. Because we say that capacitor can be charged and discharged very fast, okay. So the power rating of the capacitor is very high, like a battery have a very high energy, okay, but battery can only
हाँ जी
charge.
पापा
Battery can be mic.
वो दूंगी
Please, your
नींबू ना डलवाना
switch off your mic.
हाँ बस कर रही हूँ
Mic, please. Okay. So power, like I was talking about the battery. Battery has a very high energy. Okay, but battery discharge very slowly. Yeah? Like your laptop battery, your mobile battery. Capacitor will charge in seconds or discharge in seconds, okay, but battery will give very slow energy, okay. It has a high energy but the delivering ability is slow, okay. So where you want energy at a brisk race, like racing cars, that racing cars, there you have to design special devices like super capacitors, okay, capacitors where you can deliver and give a power in a burst, okay. So that is a definite difference between energy and power. Power is the ability to how much faster you can give the energy, and uh, that will define its power, okay. So that is, we have completed all the introduction of these things. Now we'll come to our main job of circuit analysis, okay. Now we learn the methods. How can I solve a circuit? Do you want a break or shall I continue? Because this is the 1.5 hour. How much class is there? This from 6:30 to 8.
20
So
minutes more, sir. We can finish it.
we can finish it. 20 minutes or more there. We can finish it. Okay. Now just let us discuss techniques. Okay. Now we are starting our syllabus. So network and how to solve a circuit. Okay. Network analysis. Okay. So there are many ways you can solve a circuit. Okay. The first thing is using basic laws. Basic laws. Okay. If a circuit is very simple, like if I give two resistance, the voltage, or very simple kind of circuits, then I can simple solve that circuit. Okay, again I'm repeating, emphasizing what circuit solving means. I want to find the current, voltage, or power in the circuit. So I can use basic law. What are the basic law? I can use Ohm's law. I can use Ohm's law. Second thing, I can use the Kirchhoff's law. There are two laws, Kirchhoff's. Kirchhoff's law. Okay, there are two Kirchhoff's law. One is Kirchhoff current law, Kirchhoff voltage law. First, we'll discuss Kirchhoff's voltage law. We short, we call it KVL. And then we have Kirchhoff's current law, which I call KCL in short. These are the basic laws. Okay, because some circuit is simple, I can use this method. Now there are some techniques. Okay, techniques. If circuit become complicated, then you can use techniques. There are two important techniques. One is called nodal analysis, and the second is called your mesh analysis. Okay, nodal analysis means basically this is the Ohm's law always you require. Okay, so this technique is a basically combination of solving circuit which using Ohm's law plus KCL. Okay, if you combine these two things, that will become a nodal analysis. And if you want to do mesh analysis, you know the mesh analysis, what you apply voltages in the loop. Okay, so if you use Ohm's law along with a KVL, Kirchhoff voltage law, that comprises together, that forms a mesh analysis. Okay, so these techniques are sufficient to solve any circuit. Okay, you can, if you know these techniques, you know this, you understand these laws, 3 laws, and you know this technique, you can principally you can solve any circuit. Okay, still we require some more methods in order to improve the efficiency. That means if I want to solve a circuit, a complicated circuit which may require 3 minutes or 2 minutes or 5 minutes using this technique, can I solve that circuit within 1 minute? Okay, for that, then for that purpose we have to use some network theorems. Okay, which will increase our efficiency solving any circuit. So that is, next will be your network theorems. Okay, what are the network theorems I'm going to discuss? There are many network theorems. I'm not going on all the things because we are not students of electronics or electrical engineering. Okay, we are student. Okay, so the amount of skill we require, I will focus only up to that part. Okay, because our questions will not come very complicated. Okay, this is the basic things we require. Okay, that's why we are learning this thing. So this will be superposition principle, superposition theorem, very important theorem. We'll use this one, and the second will be, after superposition theorem, the next, which is the most important theorem, is Thevenin's theorem. Thevenin's theorem. Okay, which is mainly we are using this one. We can mainly will be, this will be applicable when I will use and the operational amplifier circuit. There we can use superposition principle. Okay, otherwise this is sufficient. This one theorem is sufficient to solve most of the circuits. Okay, and then there's one more version of this theorem, not the Thevenin's theorem, that is called Norton's theorem. Norton's theorem. Norton's theorem. Okay, that you can say this is only one theorem, but okay, the naming is different, so you can keep it. And the next is maximum power transfer theorem. Maximum power transfer theorem. So these 4 are important theorem. If you want, I can teach you one more source transformation technique, which is basically result of Thevenin's theorem only. Okay, Thevenin's and Norton's theorems. Okay, so that is source transformation theorem. So there's a summary of this 2 theorems. This is called source transformation theorem. Some circuits you can get benefit if you know this source transformation theorem. Immediately you can solve any circuit without giving much time. Okay, just so these techniques are just for increase our efficiency. So this much if you know, I think that is sufficient for to handle this electronics course. So coming 1 week we'll be only solving these things. Okay, so the just give me let me give one example with basic laws, and we'll continue Kirchhoff's law tomorrow. Ohm's law all of you know. Okay, so let me just start with it today, Ohm's law, and then we'll continue later with Kirchhoff's law, and then techniques, and then theorems. Okay, now Ohm's law, you all of you know. Say Ohm's law. Okay, so Ohm's law is what? If there is a resistor R, okay, and a current I is flowing. Okay, if I want what is the voltage, if I now again V is equal to IR or V is equal to minus IR. Okay, that depends how I'm measuring the voltage. So how I'm measuring, that will be how you're measuring, this will be given by this thing. If I measure like this, so I know current is moving, so this is a higher potential. Current can only move from higher potential to lower potential. Okay, so this potential will be high, this will be low, the drop will be V equal to I. So voltage drop will be IR. Okay, because I'm moving from higher potential to lower potential. Okay, so and this is called voltage drop. When I'm coming from higher to, so this is a voltage drop. A voltage drop is V equal to IR. Now same question, same circuit, same resistance R is there. Current is also flowing here, but I am measuring voltage like this. When I say put plus here, that doesn't mean this is the higher potential. This is how I am measuring the voltage at this point with respect to this point. Where current is going now this is a higher potential and this is a lower potential, but I am measuring oppositely. That's why I'm putting this plus minus. So here V will be, tell me, V will be, what is V equal? V will be what? V will be what now?
Minus IR.
Minus IR. Suppose if I say here, if I know I, say I is say 2 ampere, R is say 5 ohm. Now voltage drop will be 10 volt here. And same circuit, I is 2 ampere, R is 5 ohm. But if I am measuring voltage, let me give terminals name also, VA, VB also. So VAB, VAB will be 10 volt. And here V, if I measure VBA, of course that will be opposite of that one. This will be minus 10 volt. Okay. So this is a sign convention. You should always remember while applying Ohm's law. Ohm's law is not always IR. Okay. If you are measuring the if you are measuring the opposite of current, this is higher potential, this is lower. So if I am measuring like this, then it will come negative. If I'm measuring like this will come positive. That thing you should understand. Okay.
Sir, actually, this in the first circuit, like current is going from positive to negative.
Yes.
Here, current is going from the left from right to left, but we are measuring from left to right. That's why it's coming minus. Is it so?
Yes, correct. Okay.
Okay.
I am forcing to current move from A to B. So obviously this is higher potential, this is lower potential, and when I'm measuring this one, this voltage difference is coming positive to me because this is a positive, this is a negative, this is higher, this is a lower. So voltage difference should come positive. I'm getting positive voltage. Here same question, but now I am measuring the voltage reverse. Okay, I am measuring the voltage of this point with respect to this point, because this point is at lower potential, and with respect to how much voltage drop is there, that will become negative because this is a lower potential. Na? The voltage of B is less than, this is a voltage of VA. This is a voltage VB. Here VA is greater than VB. So VAB is coming positive. Here VA, VB, here also VA is greater than VB, but I am measuring VBA. VBA is VB minus VA. This is the lower, this is the low, this is high, so it will come negative. Become negative sign. That's something. Okay. So I think you have you may have next class. Shall I stop here or shall I continue? Okay. Chalo, let me do one more simple problem. Ohm's law, and then we'll stop. Okay. Say so we have not learned anything so far. So only I'm using now Ohm's law only. Okay. I'm trying to solve all the questions now only using Ohm's law. So say I have a 10 volt battery. Say this is the 5 ohm resistance. Say this is a 10 ohm resistance. This is a 10 ohm resistance. Okay. Can you find how much current is coming through this battery? I want to find how much I is coming. Okay, I want to use only Ohm's law. Okay, so Ohm's law only. So Ohm's law says V is equal to IR. Okay, so I want to find how much voltage is supplied by this battery of 10 volt. Okay, for that I should know how much resistance is across this battery, R equivalent. If I want to find any circuit, any source, how much current is giving, if I know that the voltage difference of two terminals, like here I know the difference between here and here is 10 volt. Now between these two terminals, how much resistance is there equivalent, then you can find how much current is giving here. How much resistance is there? Tell me. What is R equivalent here?
10 ohm.
So
10
these two resistance are in parallel.
Yes, sir.
So parallel means R will be, say this is R1, R2, R1.
1 by 10 plus 1 by 10.
Okay, so that is because basically R1, R2, R1 plus R2. Okay, if I want R equivalent of these two. Okay, so here this resistance also there. So equivalent of this one and that equivalent will be, so let me, because there are some first year student also, so I'm doing this little bit in an elaborated way, but otherwise it is very simple. So now this is 10 volt. Okay, so this is a 5 ohm, and now the sum of these two parallel, 10 into 10 plus 10 plus 10, that is 100 upon 20, that is 5 ohm. So this 5 ohm will also come here, 5 ohm. Now this 5 become 10. Okay, so I want I, so I will be 10 divided by 10,
1
that is
ampere.
1 ampere. Okay, so I think this is a simple circuit. Okay, so we'll go slowly higher. We'll increase the complexity of circuit slowly. Okay, this is simple circuit. Let me put a one more question. Okay, say I have a current source. I have a current source. Say that is 2 ampere, and I am putting 2 resistor across it. Say 10 ohm, 10 ohm, 10 ohm, 10 ohm. Okay, I want to find the voltage across the current source. Okay, just 1 minute, 2 minutes more. So find the voltage across current source. Okay,
10 volt.
find the
So what is the question, sir?
find the voltage across 2 ampere current source. Find the voltage across 2 ampere current source. So if you want to find, so again you have to just think how much voltage is across this source. The source, the voltage across source is IR. I already, you know, this 2 ampere is giving, you find the R equivalent, this will give you the
5 ohm.
so what is the R equivalent, tell me?
5 ohm.
So 10 parallel, you give you 5 ohm. Now 2 ampere current is
10 volt.
coming.
It's
10
10
to,
volt.
so here it will come 10 volt, and this
Yes.
voltage is always same in parallel. So whatever voltage here, that will be same here. So your V will be 10 volt. Okay, 2 into 5, that is 10 volt. Okay, so I like to stop here because what if you keep continue, then one day you should not cover many things. So today class was just an introduction. Okay, tomorrow onwards we'll be on our line. Okay, thank you.
Thank you, sir.
Sir,
Tell me.
so just move 1 minute, sir.
Yeah, tell me. Oh, you have to write.
Oh, no, got it, sir.
Okay.
Thank you.
Thank you.
And